everyone, so today we're going to be looking at day 3 of Acing the Algebra EOC, and today is a pretty basic, straightforward day that we've covered a lot in this class. So to get started, what we're going to look at first is key features of a linear function, and this is something that produces a line. So the first thing that I want to look at is the y-intercept. So the y-intercept is where it crosses the y-axis. Y-intercept, y-axis. And then the next one that we have is going to be our x-intercept. Now we could also call this a solution or a zero. And this is where the line crosses the x-axis. So the only other thing that I want to do with this graph is find the slope. And that's where we have to go to Desmos and we use y1 squiggle, mx1 plus b. And again, those are the number 1, not commas. So let's go to Desmos. Remember, we have to add a table, and I'm just taking the 2 points that are from the table, from the graph. So we have x and y, and those 2 points are at 0, 4, and negative 2, 0. And those are the 2 points that I'm going to be using. So once you type them in, your points should look similar to what you have on your graph. And then below that, I'm typing in y1, and then the squiggle is going to be shift and the button beside 1. So if you look at the button beside 1, you have to press shift to get the squiggle. Then we have mx1 plus b. And that's what gets us our graph, our slope, our y-intercept, everything we need to write the line, find the slope, etc. So our slope is at 2, so y equals 2x plus 4, because that is our y-intercept. Let's look at the quadratic function, and if at any time you need to pause or slow down this video, just go ahead and do so, because I am trying to go quickly through this material since it's stuff we already know. Now, the next one that we're going to be talking about is a quadratic function, and I'm going to start over on the right with my x-intercept. Because again, the x-intercept has several names. We know it as our zeros, our solutions, and our roots. And again, this is where the graph crosses the x-axis. So keep in mind that whenever we are looking for our x-intercept, our zeros, solutions, and roots, I can have 2 solutions, which is what we see here. I can have 1 solution, so that's where I draw a graph. That's where my graph only crosses or touches at 1 point. Or I can have no solution, where my graph doesn't cross the x-axis. So keep in mind that you can have those kinds of solutions as well. The next thing that we're going to look at, again, is the y-intercept. And that's where it crosses the y-axis. So if you ever come across a question that asks, what is the y-intercept, just look at the point on the y-axis. The next thing that we're going to talk about, and what we know it mostly as, is the maximum and the minimum. But we call this the vertex. So for this particular graph, my vertex is at 2, negative 8. I'm looking at this point right here. And then something that is closely related to this is our axis of symmetry. And we will always write the axis of symmetry as an equation, which is x equals some number. So the way that this is related to the vertex is that it goes through the x value. So my axis of symmetry for this graph would be x equals 2, because again, I went through 2 on this graph. And that clears up and concludes all of our key features review for this lesson. So let's take a look at domain and range. So we have just a few short definitions to go over, and then we're going to look at the 6 questions that follow. So the domain is going to be all of our x values. Range is our y values. And we, on a graph, can have open and closed circles or points. So the one that actually looks like the letter O is an open point, meaning that it is not equal. So if I was to draw out my inequality symbols, it's less than or greater than. Then if I have a closed circle, so it's the filled in one, so closed, this means that it is equal to. So I would write less than, equal to, greater than, equal to. So let's take a look at number 1, and this is asking us what is the domain for the following graph? And domain is our x values, so I could, based on that, get rid of 2 answer choices. The next thing we need to do is figure out what is the order for our inequality symbols. So if I look at 0, I have a closed circle, so less than, equal to. And then at 2, it's open, so it's just less than. So it follows that order, which would be C. 2 and 3 takes us back to first semester when we were talking about discrete and continuous functions. And if we remember, a discrete function is something where I'm buying or selling or counting a set number of items. And if I'm looking at items or buying items, I have to buy whole numbers. There's no in between. So let's look at number 2. This one says the total cost, C in dollars, to create calendars for a fundraiser can be found using the function 5.5U plus 25. And U represents the number of calendars made. If there are at least 10 calendars, what is the possible range for the function? So here range represents the total cost. And always, 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 your Y value is going to be the total cost. So again, this is Y, which means the number of calendars we're selling or whatever is X. So if I draw a table, I can sell 10, 11, 12, so on. I need to find the total cost for those numbers. So what I'm going to do is go to Desmos. Let me minimize this a little bit. And what I'm going to do is type in this function given to us, except I'm using x. So 5.5x plus 25. And I'm not really concerned about the graph. I want to look at the table. So I'm going to go to Settings, Table, and here I can kind of see all of the prices for my calendars. So at 10, it cost $80. 11 cost 85 and a half, and 12 is 91, and so on. So the only answer choice that really matches this data is B. Again, the reason it can't be C and D is those include all of the values in between. I don't want the in-between values. I only want whole numbers. Let's look at number 3, and number 3 is kind of similar. So here, what we're looking at is a gym who charges a $15 registration fee and $5 per session. So I'm paying $5 for the entire session, not part of it, not more than that, per session. So if X represents the number of sessions, and the total cost for going to the gym is represented by the equation, if Mario will be going no more than 4 times this week, what is a possible domain for the situation? So again, domain is X, and I'm going no more than 4 times this week. So 1, 2, 3, 4. The only answer choice that looks similar to this is F, because again, I'm paying for the entire session, not part of one, not 3/4 of one. I am paying 5 per every time I go. So that's why F is the correct answer. Number 4, we're given a graph and we need to find the domain and range of the graph. So the first thing I look for on these graphs is if it has arrows. So here I have 2 arrows, which tells me that my domain is going from negative infinity to positive infinity. So again, that means all real numbers to us. So domain is all real numbers. Again, if you see arrows, domain is all real numbers. The next one, I have to graph this. So let's go to Desmos and type this in. So our equation, we have negative x squared minus 14x minus 50. And we're going to look at the graph for this. I see that my graph is open downward, or it is continuing downward. So it looks like this. So again, range is y. We can get rid of a and b. And then, since it's open downward, it's going to be less than or equal to. Because again, down is less than or equal to. So we have one more question left. We're going to look at number 6. And so we're given the graph of a quadratic function. We need to find the domain. So again, domain is x, so we can get rid of b and c. Because if I see f of x, that's the same as y. So again, f of x is the same as y. So here, what you can do, since there's a lot of numbers, is you can organize this into a table. So we have 0, 4, 2, 5, and then 6.5, 0. So we're looking at it going from least to greatest. So 0 to 6.5, which is A. If you have any questions, please let your teacher know. The quiz should be available on Canvas. Good luck, and that's it for today.